Okay, in this problem we're going to be using Hess's law to calculate the enthalpy of a reaction that we don't know the enthalpy of already. And what I mean by that is there are a number of different chemical reactions where the enthalpy has been determined, all right, the enthalpy change. And how can we take those reactions with known enthalpies and calculate the enthalpy of a reaction enthalpy of a reaction that has not been tabulated, of some reaction where the enthalpy is unknown? Can we use those two reactions in this case to calculate the enthalpy of this third? And the process we're going to use is something called Hess's law. There are going to be three different things that we're going to do. We're going to have to make sure that we get everything on the correct side of the reaction arrow, so that when we add these two together, they're going to equal this. So we're going to rearrange them, move them back, switch them around relative to the reaction arrow. And then we need to make sure that we have the correct number of reactants and products in those two equations to match this unknown reaction. Lastly, we're going to add everything up and we're going to calculate what the enthalpy will be. So again, this is what I'd consider a fairly basic Hess's law problem. We're going to take two reactions with known enthalpies and calculate the enthalpy of a third. So the first step, like I said, is to make sure that we get the products and reactants on the correct side of the reaction. For that, we are going to take a look at this unknown reaction, the reaction that we don't know the enthalpy of. And we are going to look at each of the different reactants and the products and compare where they are in this equation relative to where they show up in those known reactions. So, to start, let's look at this carbon, just carbon as a solid. Okay. We are going to look now and find carbon as a solid in either one of those two reactions. If we find this in multiple reactions, we're just going to leave it alone. We're going to leave it where it is for the time being, and it will work itself out. If we do find it and it's only in one reaction, we need to make sure that in the reaction we find it in, it's on the same side of the reaction arrow as it is in this final unknown reaction. So we're looking for carbon as a solid. The only place that we find it is in this first reaction with a known enthalpy is right here. And notice it's on the left-hand side of the reaction arrow. We need that carbon to be in the left-hand side of the reaction arrow. If it's on the left-hand side of the reaction arrow there, it needs to be on the left-hand side of the reaction arrow here as well. And indeed, relative to the reaction arrow, it's on the left-hand side. So we are good so far with the carbon. So I'm just going to put a little check mark above it to say that we took care of it. Work on the next reagent, that's oxygen. Remember I said if we find the reagents in both of the different reactions, or all the reactions that we're using to combine to find the enthalpy of the unknown reaction, then we just leave it alone. So here's oxygen and there's oxygen. It's in both of those equations, so we are not going to do anything with oxygen. We're just going to, as long as we take care of everything else, the oxygen will work its way out. Carbon monoxide is left, CO is a gas. We're going to look for it. It is not in the top reaction, but it is in the bottom reaction. CO as a gas is here. Here it's on the left-hand side relative to that reaction arrow. Okay. Here it's on the right-hand side relative to the reaction arrow. So what we're going to need to do is we're going to need to reverse this equation so that carbon monoxide is on the right-hand side of the reaction arrow, just like it is in the unknown reaction. So to do that, I'm literally just going to switch around the chemical reaction. So I'm going to take carbon dioxide as a product, make it a reactant. And I'm going to take carbon monoxide as a reactant, and 1/2 oxygen as a reactant, and make them both products. Now when I do that, I'm not going to use this equation anymore because I've reversed it. And I'm also not going to use this enthalpy as it is. Because remember, the properties of enthalpy and enthalpy of reaction is when we switch the reaction around, the enthalpy changes sign. So our delta H2 is now plus 283 kilojoules as opposed to minus. So now it's gone. We started with 2 reactions, we rearranged this one, now we still have the same 2 reactions. Now what we need to do is we need to make sure that we have the correct number of products and reactants in those equations as we have in our final reaction. Notice we've already taken care of CO. So look here, we have 1 carbon as a solid. We need to look at these reactions. Okay, we find carbon as a solid, and there is 1 of them here and 1 of them here. So we just leave it alone. Put another check mark above that carbon. Oxygen, again, we're just going to leave alone and take care of everything else because oxygen's in multiple equations. And you'll see it will work out as long as we take care of the other 2 species. So carbon monoxide, we have here. It's now on the right-hand side, which is just where we want it. We have 1 of them in this reaction, 1 of them in this reaction, so we're good on number. Once we've gotten everything to the correct side of the reaction arrow, and we've gotten the correct number, then all we have to do is we need to take these 2 reactions and add them together. It's like a big addition problem. So I'm going to take everything that's a reactant, everything on the left-hand side of the reaction here, and put it on the left-hand side of the reaction arrow down below. Carbon as a solid, plus O2 as a gas, plus carbon dioxide as a gas. Now we draw the reaction arrow. We're going to take all the products, put them together on the right-hand side. Carbon dioxide as a gas, carbon monoxide as a gas, and 1/2 oxygen as a gas. So we've just added everything together. We've combined those 2 reactions. Now what we can do is we can look to see if there's anything that's exactly the same on both sides of the reaction arrow, or if we find the same species, exactly the same species on both sides of the reaction arrow. So I've got carbon as a solid here on the left, and I don't have it on the right. So I can't do anything with it. I have oxygen here as a gas, and I have oxygen here as a gas. Same chemical species. So what I can do is I can cross out 1/2 oxygen on each side of the reaction arrow. So now I don't have oxygen, I only have 1/2 oxygen left over. What do I have left? Carbon dioxide, I have 1 of them here and 1 of them there. They're the same, so they cross out. So what am I left with? Let's just rewrite everything. Carbon as a solid plus 1/2 oxygen as a gas. I've got my reaction arrow, and I've got carbon monoxide as a gas. Compare this to what we found, or what we started with up here, what we wanted to find the enthalpy of. Carbon as a solid plus 1/2 oxygen plus 1/2 oxygen goes to carbon monoxide as a gas, carbon monoxide as a gas. That's the way you've done the problem correctly. This equation works out to be exactly the one that you want it to be, then you have solved the problem correctly. Now notice, we're not asked just to get this equation though, we're asked to find the enthalpy. So just like we added those 2 equations together, we can just take these 2 enthalpies of those 2 reactions and we can add them together. So the enthalpy of this reaction is just going to be equal to minus 393.5 kilojoules plus the 283.0. Just going to add those 2 enthalpies together because we have added those 2 reactions together. And if we do that, the answer that we should find is minus 110.5 kilojoules. It's a basic Hess's Law problem.